delay. There was a loose contact, but I think we can get started now. So this morning's talk is called Faster. My name is Sidhu. My background is that I'm mostly dev, less ops, which is why I think you'll find my perspective on this tends to be a little more biased in that direction. But having said that, I think the focus of this talk is about, we've already got all the low-hanging fruit of DevOps, right? We've automated a bunch of our infrastructure. We've taken care of all of that, but we still need to go faster, right? So what are some of the simple things we can do to go even faster than we have once we've gotten all the low-hanging fruit taken care of? So that's the focus of the talk. I'm Sidhu. You can find me on Twitter at that handle. And a quick shout out to the ETT. The ETT is the non-profit trust that is supporting all of these events. These are all the events that we do and communities that we support, and we'd love to have you at our other events. So let's dive straight into the talk, right? What we want to do as part of any engineering team is to delight our customers. And by our customers, I don't necessarily mean the end user, though that is sometimes the case. By customer, I mean anybody that interfaces with engineering, which is product, sales, marketing. I mean, it's different. Each of you will have a different set of customers. But what we want to do is to give them a fast, flow of features into production, everything they want, everything they need, as they need it. You know the holy grail, right? And we want to continue to do this after we've got all the low-hanging fruit sorted. We've done all the usual stuff, and we still need to go faster. We need to keep increasing our pace. What do we do? And you will notice, and I will end the talk again with this point, and this is really the backbone of everything I'm going to talk about, is beyond a certain level, once you've got all the big stuff, now going faster is not about pushing harder. It's about being smoother. Right? It's about shaving off all those, it's a little bit like sports, maybe, where you're shaving off all the small stuff. A gram here, a gram there, you save a kg on your weight, that kind of a mindset. And I tend to look at this entire question along two key axes. How long does it take us to get a feature to prod once it's done? That is, once it's dev complete. Different people have different names for this. But we finish developing the feature. How long does it take us to get it live in a hard prod environment? And the second axis along which I look at this question is, how long does it take us to restore something that has gone down? So this entire talk is going to focus along answering this question of how do we go faster along these two axes primarily. The root of a lot of what I'm talking about is lean and agile. And there's a lot of jargon about this already to excess sometimes, in my opinion. But one thing I do want to call out is the heart of the lean methodology is the manufacturing assembly line, right? And identifying errors. You guys would have heard all this spiel, right? So this is the favorite picture. This is a Toyota assembly line. What is interesting over here is you may notice up there in the it's a little hard to see in this resolution, but there is a pull cord, right? For this guy to pull. And he will yank on that every time there is an error on the production line, right? Something goes wrong, he yanks the cord, the entire line shuts down until the error is identified and fixed. So do you guys have a sense of how many times this happens in a day? Anybody? Audience question? So the average number across 15 lines was 3,000 times per day, right? So 3,000 times per day across 15 lines were being shut down because of some error. Now, given that this is the methodology from which we're deriving so many of our principles, the question becomes, where is our production line? We have this stuff, we have stand-ups, we have pairing, but where's our production line, right? So I'll leave you with this question for a moment, and I'll come back to this as we move through the talk. But I do want to plant this particular seed, that while we draw a lot of analogies to manufacturing, those analogies do break down at some point because some of the core concepts do not necessarily exist in the same format. Now, this also is a common thing, right? DevOps culture practices. Without culture practices, there is no DevOps, etc., etc., etc. But why is it important now? Why has things changed? We are talking about this stuff. I mean, DevOps is old. Chef and Puppet have been around for years now, right? As a concept. Now, what has happened consistently in the last 7 or 8 years is it is more and more common for us to treat provisioning, infrastructure, all of this as SaaS, right? The fact that we are using an API or whatever is commonplace these days. And we also now accept this fundamental premise, this conflict, if you will, that if we want to do stuff stably, which all of us do, right? We don't want bugs, we don't want our system going down. The first thing that happens is we say that stability comes from reducing the amount of change, right? Fewer things we change, fewer things go wrong. But the counter pressure to this is the fact that every time a new feature comes up, there is going to be change. So this is the balancing act that we have to deal with. And when we move fast, things are going to break. Because when the definition of moving fast is we're going to have boatloads of new features coming in. Many of those features are unverified. Many of them are going to go for market fit through testing. We're going to get data. Some of that stuff we're going to pull out later. So this kind of high churn is going to break things, right? So this becomes a key adage, right? Lower the risk of change and increase the speed of change. And sometimes this seems to be a contradictory goal. So we solve this through these key principles. Automate everything. Be delivery ready. That means whatever we are doing is ready to go live constantly. And most importantly, common issues must be dealt with automatically. There is no question of manual intervention constantly for the same thing that happens on a daily basis. And this is our common stack for dealing with this. We continuously integrate, we automate infrastructure, and we focus on ensuring that there is very high level of communication across functions. So we come back to this question. How long does it take to deploy a feature to production? Right? So this is actually an audience question for me as well. On average, how long do you guys see the cycle time be from the time that you finish a feature, the dev team says that I am done building, to the time that it goes live? Can I get a sampling from the audience, please? Anybody? Yeah? 6 weeks? 2 weeks? Sorry? 2-3 hours. Anybody else? 4 weeks? Okay, so we have a fairly wide range here, right? So one of our goals in terms of what we are doing is to continuously push that number down, wherever we start from, and it usually takes time because these things are not isolated. There is no, and that's the point of this talk, there is no one lever we will pull where that number will halve. That is done. We've already done that. Now what is it that we are going to optimize to? Cut that. So this is one of the most interesting things that I find that we can do, right? Which is continuous integration. We all talk about. Sure, everyone's got a CI server, but is continuous integration really just sticking a CI server in there? This I find is the most difficult thing to convey. Continuous integration means we can't do stuff like this. Continuous integration means every commit is continuously integrated. It's not that we take off for days or weeks on a different branch, right? Our goal is to change our graph from what is on the left to what is on the right. All too often what happens is we focus on the tools and the methodology, not the eventual outcome that is needed. And what we eventually want is to reduce those coarse-grained steps, the big steps of every deployment, down into fine-grained steps. Which means that we have to look at every piece of our delivery system. And the feature branch thing that I mentioned is one example, right? Like all too often, we end up in teams where, yeah, we are doing continuous integration, we are doing all of this, but then for one reason or the other, features are integrated after days, weeks, or months, right? So the feedback loop is very coarse. And this really is what we're looking at. If you remember the original question I posed a few minutes ago, this really is our assembly line. It's an abstract thing. It doesn't really exist in the real world, right? It is the system on top of which our code goes live. And you need to be able to have this come to a halt every time there is an error. And that halt needs to be propagated to the whole team. So everybody knows there is something fundamentally wrong with the line, that everyone needs to down tools, fix the issue consistently, and then bring the line back up. So the real deal is not whether we have a CI server or any of these tools. The question is when we step back and go to a whiteboard and draw out what our system is. Maybe it uses a CI server, maybe it uses 4 or 5 other things. But does it look like this, something like this? And does the whole system come to a halt when there is an error? And is the entire team notified when there is an error? And do we focus on fixing that error and bringing the whole thing back up again quickly? Right? Which is the next point. How long does it take to deploy a service reliably and repeatably? Because all too often the question that is focused on is how frequently does the service go down? But that is not the important question. Because if we are dealing with a high frequency of change and a lot of features, things are going to go down. The question is, after it goes down, how quickly does it come back up again? That is what really matters, right? So a few things that we can do to smooth the process out, right? Infrastructure as code, all infrastructure as code, with no exceptions, right? So consistency. There should be no edge cases in our system where some subset of our system is not treated as code, it is not automated, is not managed through software. Manual changes are fundamentally dangerous for this simple reason: error rate. If there's a human in the loop, mistakes are going to happen. It's a question of not if, it's a question of when, right? So our goal is to reduce that error rate, so we will avoid manual changes aggressively. How long does it take us to restore a service? This is our typical narrative. This will be familiar to all of you guys. One server, this is the story that goes in there, right? Boot up, set hostname, install NTP, resolve conf, static IP, default gateway, blah, 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 right? Every time a new machine comes up, over and over again. Now, the reason I'm putting this up is we have to realize that even if there is one subsystem in our overall system that is being handled manually, just look at the number of steps that are involved. Someone's going to screw it up. It's going to happen, right? And then the usual answer over here is we'll create images. But even images are not a great way to track incremental change. Because what happens is every day our systems evolve, right? And it is not easy to document that incremental delta using images. So why not document them in an automated way, aggressively, across the board? Next thing that matters is treating your app as a first-class citizen of the OS. All too often what happens is we are deploying on a CentOS system. Everything else is RPM, except our app. Right? Why? It should not be the case. Whatever we're doing should behave and fit into the system like all other applications fit in. We should not have a special status for our app. This kind of consistency also means that a lot of tooling which the system itself offers us now becomes available to our application if we attempt to be consistent in this respect. All the simple tasks, basic tasks that routinely are needed must be automated without exception, right? So these are some of the standard stuff you see: restarting stuff, monitoring stuff, getting data, scaling stuff up. And this should become our new key metric. All too often, and I just mentioned this, all too often what becomes an obsessive focus is mean time between failures. But what is important over here, and I'm trying to emphasize, is when you are trying to go very, very fast, errors will happen. We are changing features so frequently that stuff is going to go down. What really matters is how much downtime does our end customer experience. Because if we try to focus on the first metric, we will build a system which is unable to change and is constantly pushing back against change, when what the ultimate goal is actually to change very fast. The second metric ensures that you are focusing on the user experience, not a metric which is disconnected from user experience. So we need to optimize fundamentally for resilience, right? And we need to accept that there is an error rate and mistakes are going to happen. So most of our infrastructure is now automated. This entire, I mean, one of the things that really bugs me to this day is, you know, the point of calling DevOps is that it's dev plus ops, right? There is no real difference between dev and ops. And yet still, no matter what we do, that difference does come up, right? So I want to re-emphasize over here that that mindset needs to change, that we cannot have siloed teams around this kind of stuff anymore. Otherwise, focusing on resilience becomes difficult. That ball keeps getting thrown to the other side. No, that's not my problem. Hey, QA was supposed to take care of it, man. No, ops is supposed to take care of it, man. Like, it's pointless. We now have a completely integrated system. Everything is software, right? So generally, we should be able to treat it as one system. And then focus on what it is that our business really needs, right? Which is information to make decisions. If we focus on our job being to provision systems and automate all of that, that's missing the point. That's supposed to be a background task. We do it and then it runs in the background, nobody notices. What we're actually doing is getting the business these kinds of numbers to answer questions which really matter. And also move code fast, really fast. So this is the kind of numbers that Amazon runs. Right? I'll just give you a moment to look at the numbers that are being thrown around over there. These are not small numbers. And the question is, at this level of the game, where you are doing 5, 10, 20, 30, 50 builds, releases to prod a day, right? The game's a completely different thing, right? So what I would focus on as the majority of takeaways, and I'm going to take a little bit more time here, is don't log into boxes, right? How many of us still have 1 or 2 machines sitting somewhere in our infra that you need to SSH into, right? I'm sure that's always there. We never must log into boxes. Very important. So far, I'm guessing there is, everyone in the audience is seeing this at some level. There is a push to microservices now very aggressively. It's been going on for 5, 7 years and now it's going bonkers, right? So everyone is dealing with a prod system that consists of a half a dozen, 1 dozen, 2 dozen. Some people we deal with 500, 1,000, 2,000 boxes, right? Each of these running dozens, 2 dozen, 3 dozen microservices. So if we are coordinating this manually, it is a nightmare. There is absolutely no question. And the worst part about this is if you let it last for any length of time, it becomes endemic. And then as the number of microservices grow, you will end up going crazy with this thing. And then it becomes too late. This is not something that's easy to roll back once it's ingrained in the culture. So service deployment must be automated. And this mindset, where if something goes wrong, like how many people have run into this situation where there is a critical prod bug that was discovered and suddenly everyone is doing putty on the server, you know, log in, go change some code, restart this, restart that. I'm sure we are all familiar with that kind of like a crazy high pressure prod release situation. This I cannot emphasize enough. As a mindset, any hotfix, no matter how bad, how critical, how radical, must go through as a standard deployment process. No question about it, right? As long as we treat it as an exceptional circumstance, it will have a high error rate. So we must get to a point where every high criticality bug that pops up, where people are jumping and there are fires lit and everyone is like, what is going on? Someone's going to get fired. Even to that level, that deployment must be a routine deployment, fully automated. Make the change, commit it, it goes live, nobody even knows what happened, it just went live. Service discovery, fully automated. So previously I talked about coordination between services, right? So there should be no manual aspect there, no human communication needed. The discovery of a service, whether it is up, where it is running, etc., again should be automated. Cut out the human component as much as possible. And ensure that your deployment is a completely independent action, which means reinforcing my previous point, all deployments, earlier I talked about emergency, hotfix, crazy kind of stuff, but really deployment should move into the background. Like how many of us have deployment as a key event? A lot of us, I'm sure, right? Like show of hands, prod deployment, key event. Everyone is on, on call and oh my God, who knows what's going to happen. That moving from there to a point where, I mean, you can imagine, you saw the numbers for the Amazon thing, right? With that many deployments, do you think those people would get any sleep if every deployment was like a mission critical, everybody stay awake all night kind of situation? Obviously not. So what I'm trying to say here is move deployments to the background. Nobody should care. Yeah, deployment happened, big deal. 5 more happened, okay, nobody knows. I didn't even know. Someone made a commit here, it went live there were no prod bugs. No stress, right? So that's kind of a holy grail. And stop focusing on hiring DevOps, right? We're hiring developers. So this is something that I do like to talk about a little bit more, because at some level I think this is endemic of the Indian industry. It's not just in DevOps, right? Front-end dev, back-end dev, middle-end dev, DB dev, JavaScript dev. The problem is that the moment you have this kind of a mindset, you're automatically creating silos. My personal opinion is all of this exists not because we want it, but because the recruiting industry doesn't understand anything else. They're like, dude, give me some convenient labels. You need to hire for this function. Like, you've given me a JD. On top of that JD, what do I write? Right? And somehow that is coming back and becoming our designations. So it's a really weird sort of toxic situation. But this mindset needs to change, right? There should be no separation of responsibility along those silos. Like in this talk, I'm focusing on DevOps, but I generally believe in this anyway. Like I don't like that silo between dev, QA, dev, DevOps, front-end dev, back-end dev. These things generally add error rates for me across the board. And this is my dev side of the bias coming in. But on the ops side, I would definitely say that if you're hiring devs. We're not hiring for DevOps. And everybody that is dev is also ops. And that's very, very important, right? And to reiterate my original starting point, smoother is faster. Beyond a certain point, and I hope I've done a reasonable job of conveying my argument toward this. Beyond a certain point, you cannot press the accelerator to go faster. You've already pressed the accelerator to the full. Right? Now you're not going to go any faster by trying to push it through the floor. Now you have to optimize 1,000 other things. Now this is what I jokingly call the battle of 1,000 pushes. Right? You're not going and punching somebody in the face anymore. Now you're like one push here, one push there, one push here, and you stack your optimizations up. And when you stack 1,000 of them up, you will get like a 10% improvement. And this can be very frustrating for people who have already just reaped the early benefit, right? Because you did a few basic things, you put in a CI server, you automated your prod deploy, boom, you got like 50% productivity. Now you will spend like thrice that time to gain 10% productivity. And what I want to call out over here is that delta is normal. Like, don't let it slow you down. You have to realize that low-hanging fruit were low-hanging fruit. Now for every other increment, we have to do a lot more work. At this level, at the Amazon level, the analogy is now you're playing at the highest level of the field. All the easy optimizations are done. Now it's only the difficult optimizations that take communication skills, that take a lot of softer factors. Systems modeling, you'll notice that over here, I have not mentioned a single piece of technology at all. Right? The reason for that is we tend to get bogged down talking about the technology. The point is that technology exists to facilitate a delivery system which performs at a very, very high level, which, as I just mentioned, has the goals of extremely short time from dev complete to prod, and extremely low recovery times. That is, it goes down, it comes back up transparently and quickly. Right? That's the goal. It doesn't matter what we use behind the scenes to do that, and that can sometimes be a distraction. Oh man, Chef, so cool, I'm doing this and I hate Puppet because Chef. But while that is a useful conversation in a certain context, it is very important to step back and look at the overall system and look at stuff like that graph I mentioned. Sorry, I'm going to run back because this is important to me. Until you actually plot all of this and think about it and step away from the core tech stack for half a day and just look at this and ask these questions of my overall delivery system rather than any one piece of it, we won't be in a good position to improve performance. Right? So, at this point, we are not getting faster by pushing harder. At this point, we get faster by shaving off all the small stuff. And to shave off all the small stuff, you need to step back, be a little technology agnostic, look at it as a systems problem, analyze it as a systems problem, measure metrics, and then optimize. And this, I think, is a very, very nice sort of simple, finger in the air, which way is the wind blowing, way of gauging progress, right? You shut down a service intentionally, and it just comes back up within the stipulated time. You're sorted. Yeah? So, that's my talk. Thank you. I think I ran considerably under time, but we have more time for Q&A. Yeah.